You don't need to be so quiet. Okay, this mic is very good at noise cancellation. Okay, cancel the noise. Okay. Well, I will talk about a little bit, little bit over what is a program. If you wish to go together with me, okay, I will also show you later. You can git clone my repository code, okay, and we can use the code together. Okay, so the program is actually a piece of code. You know, you write a C code and you compile it, but the compilation is very interesting. Okay, the compilation, you know, this is what we tell you in year 1 or year 2 courses. You compile it from C to assembly, in machine code, and then the thing will automatically run. Okay, and in operating system, okay, the story is not that simple. Okay, of course, like a Patrick, where are you? Do I know that? Okay, you ask a question over O2 and O3, right? Today also we will talk about it. Don't worry. Okay, so the code is like this. Okay, let's say I want to compile this code. Okay, the code contains several things. We have the number side defined directors, to define some constants. Okay, and later on I will also show you the include file thing. Okay, so I want to compile this program, and it will go through the preprocessor, and then go through the optimizer. Later on you will see how a code can be optimized and to which level it will be optimized. Okay, then we generate assembly code. I can teach you the command to generate assembly code, and then we will go to another phase. But first, let's go through these pieces of thing here. If you wish to just call for help from the preprocessor, okay, you can use GCC. How many of you don't know what GCC is? It's okay, okay, you don't need to talk, okay? Yeah. No GCC means that you're Windows fans. Okay, you never use that. Okay? Yeah. How many of you use CLAN? CLAN. No one knows what is CLAN. Okay. CLAN. No one use it? Okay. Some generation gap here again. Okay. So I open all files. Okay, do it again. They so happy to access a demo. Okay, and atom is slow. Okay, so let's do it. No, include is not good. Okay, main void. Okay, and make sure that this program is short enough. Okay, yeah, I'm lazy. Okay, test.c. This is a program, right? Usually I will compile it using make test. No, it's not test.c but test. Okay, so it will automatically compile, and when it runs it, it's okay, right? I just talked about CLAN. CLAN is under another technology, LLVM, invented by the engineers from Apple and also some community in the open source world. So you can still compile it, same options, just like GCC. It just works perfectly. Okay, of course I need to print something, or you don't trust. Okay, yeah, you don't trust. I know. Printf, high. One only, okay. The CLAN, yeah, you just do some complaint just like GCC, run. Okay, so CLAN is also a compiler, and some people already argue that CLAN is better than GCC. Why? Because the development cycle in CLAN or LLVM is much faster than the GNU-C compiler, than GCC. Their development cycle is much faster and adopting new standard in the CLAN. Okay, and GCC they are still disgusting. Okay, they're not disgusting. It's disgusting and also disgusting. Okay, you don't know what I'm talking about. Okay, go ahead. And yeah, so I want to compile this program and go through the -E Okay, so I have to clone my thing. I didn't clone my thing yet, so I just go to here. And if you don't get familiar with GitHub, okay, I assume that you know what is download, okay? So if you're familiar with GitHub, so you will know what I'm doing. Yeah, wait for a moment. So all I'm doing is I just copy and paste that URL and then clone, okay? So if you don't feel comfortable with it, download. Okay. So the examples, the chapter. Okay, so we are in a program part. If you want to compile all things, just type make. I will create all things for you. So the first command is gcc-e hello.c. So I wish to compile it by just looking at all the define and all the include statement and tell you what is the difference. Okay, so let's take a look. I love this command cat. Okay, how many of you don't know cat? Okay, yeah, you know dog, mouse. Cat means just dump the file content and put it to screen. That's all. Okay, yeah, dump the file content, put it to the screen. So it's cat. Okay, then I said that I will use the preprocessor to convert all the define. So what is the meaning of convert? Let's take a look. Dump out the content of hello.out. So the hello.out is generated by this command. Okay? Take a look. So forget about all the number sign thing. The thing that I want you to focus is the printf statement. What happens with the printf statement? Substitution. Right? Substitution. So it's just substitute. Very nice, right? So this is the way that GCC works. It's just first process and do the conversion, the substitution. How about this? What is this guy? How do you call it? You usually call it macro, right? So in the elite class, we will do a lot of macros. Okay? I know macro in the 普通话是什么？红，对不对？是红，对。In Cantonese, it's still called macro. Okay. Yeah, 谁说 macro 嘛 Yeah, so Cantonese, it's called macro. Okay, so this macro is also replacement, but with parameterizing effects. So you give parameters, so you will do the replacement as in here. Okay, so take a look. No, I already make it. So is this done through this command? And take a look at the include.c. So this is it. And not include.c. It should be the so swap.c. Sorry. So the swap.c here, okay. And I will call the swap. Okay, then it will expect that it will doing the swap operations for you. And look at how it's used the parameters. Okay, so this is the creation very big, okay. But look at here. It is the replacement. It just put the macro and look at the argument inside, it becomes I and J. C equals to I equals to J, but inside the macro in the PowerPoint, okay, you will find another version. It is not I and J, okay, and no, it's not I and J, but A and B. Okay, so it will do the replacement. You say I here, I will replace A with I, so and so forth. Now, if you have questions that you don't need to answer, think about it in your home or in your leisure time. Okay, the problem is. Here I have a semicolon. I have a semicolon there. And here, did I type something wrong in the PowerPoint? That exists a semicolon there. Take a look first. Take a look at the output. When the input contains the semicolon, here it contains the semicolon as well. Here, okay. Contains the semicolon itself. And this is not my questions. My question is, Okay, seems that the semicolon sucks, right? Can I remove the semicolon? Question number one. Question number two. If yes, then I hate this solution, right? How come you allow people to write things without a semicolon and you get tests and you compile it? I think it is a bad idea. How can I mandate people that if you don't write a semicolon, you'll get wrong? Now, first of all, take a look at this program. This program, if I remove this semicolon, can I compile it? We'll say yes. Only 1, 2, 3. Okay, others, we don't know what is compiled. Compile ones, okay. Okay, so I don't do the conversion, I just do the copy and paste here. Highlight, copy, okay? So I create a new file called test.c. Okay, so there's the test, oh, ugly, yeah? Do set paste. Okay, insert. Okay, so I do the color is bad, right? Can you see the color? A little bit better. Okay, so maybe I use another editor. This is good, right? No color is good. So I remove this. Can it be compiled? There's a warning. Why there's a warning is something bad here. I forgot to include. Okay. So remember, version 1 has a semicolon, version 2 don't have a semicolon. Now this is version 2. Can compile and can run successfully. Okay? So what is the meaning? The meaning that is that this semicolon can be there or not is just up to the programmer. It's just up to the programmer whether you have that semicolon or not. And my question is, I hate this idea. I don't want to invent a macro that won't check there exists a semicolon there or not. How to improve it? This is the question that I want to ask. And the solution is in the elite class. If you want to know the solution, okay, I will tell you when I will disclose it. Okay? The elite class will talk about it. Okay? I can give you a hint. The hint is use while loop. Okay? Think about it. Yeah, just a window. Okay? So let's go on and forget about the window. Yeah, some happy things. Include. How many of you know where is the include files? Standard IO.h, where is it? So just an imagine. Yeah, who's the studio view me? I don't have the studio view. Okay, so there is a system default location. Okay, so it depends on the system. Now, this is the location for Mac. Okay, I always save it in a user path. There's a so long, I hate it. Okay, so I SSH to a Linux so that you will understand. Okay, so where can I go? Okay, I can go to here. Okay, I go to a public department Linux machine. Okay, I don't go to my machine. Linux in our department. Okay, oh, too big. So this is the Linux, free. So the default location is in /user/include, and I use a less command to read it. Standard IO.h. So it's here with a license. With the defined. Can you find printf? Printf? Yeah. Oh, I found the definition of printf is here. Okay, definition of printf is here, but the implementation is not here. Okay, so that means what? That means it's actually you are trying to bring in an external file. If it is using this, okay, that means that you will go to /user/include to find that content. Now, what is the use of the content? Now I want to disclose to you using a preprocessor. The preprocessor will go to do this way. Okay, so let's go to the include.c. So I will include header file.h. Okay, and the header file.h is actually defining the add function. Okay, so why in this way? Because the include statement is actually doing copy and paste. Copy and paste. Okay, so take a look at the program after the preprocessor being processing the include statement. It's actually copying the include statement, substituting include statement with the content of the header. Put it there and put together with your main. Okay? So this is the meaning of include. Okay? It's the meaning of include. So actually you are producing a new file like this. Okay? Replacing this. Any questions? Yeah, include is boring, nothing changed. Okay? You just do a simple copy and paste. Okay? So then I will go a little bit faster. Okay? So a little bit faster is, for the compilation, we cannot say too many things. Why? Because you have to take a course called 3120, but it is going for so many years, the compiler construction class. Okay? So I cannot go deeper, and if you want to know more about the assembly language, it's not in this course again. Okay? It's a joke, not a joke for me. Okay? You have to take a minor course, which teaches you assembly language, and that minor course is even containing more stuff than our major course. 3420 in terms of our assembly language, because the minor course is actually copying one of the course which is being deleted. It's called 2420. I learned the whole full course of writing Intel assembly language in 2420. And 2420 and being copied go to the 2520. So the minor students will be more competitive than you guys, major students, because they know assembly language already. Who are minor already? Who have figured this? Oh, no. Hard to believe. No minor here. Or minor already skipped this course, yeah? I remember it will be offered. Okay? So, we will omit all this, directly give you the impression what is the meaning of optimization. Tell me, if you are the compiler, how to optimize this code? If you're the compiler, how would you improve? Okay, now first of all, who don't agree that this is a stupid program? This is stupid, right? And if you think that this is a stupid program, you want to improve it, what would you write down? Any idea? Any volunteer? Really? Because compile box. Okay. Yeah. So I just said so. Okay. We heard ring, right? My cell phone ring, junk call. Okay. Return free. Now, this is our human intelligence. Okay. So we will do the online debugging. Okay. Then whether the C compiler is that good, okay, can repeat us, or it creates some others non-clever codes. Let's go. So my make file will run through these two programs, command line, sorry. One is using what we call the optimization level 0. Optimization level 0 here. And another one is optimization level 1. Okay, 0 means nothing, no optimization. It believes in your code and don't do anything. 01 is already good enough optimization. Now let's see. Cat that I have two files generated here, the .s. Now don't get too excited when you look at it. This is non-optimized, okay? Non-optimized assembly code. So don't get too excited. Wow, what is it? Okay, will I explain it? No, I won't explain to you. I just want to highlight some of the points. The point is the $1. Okay, in assembly language, whenever you see something like this, it means a constant. $1, $2 means constant 2. Okay, so you will see that this operation, although you cannot fully understand what it is, it means that it's trying to add something called 1 to another thing called EX. Okay, so what is that? What is that? This line. So you should expect that this kind of add statement in terms of assembly language will find one line and two lines. Let's see whether there's truth. One line, two line. Okay? But we can count three, right? What is the beginning one? The beginning one is here. Okay, the beginning one you add one times, one times and add another times and return the results. So this is a non-optimized code. How about the optimized code? 01. Move 3 into EX5. Finished. Okay, so move a variable 3 and then does it. Okay? And this is the optimization process, and which is as good as our human. And of course, they can do something more like reorder your code. It's finding your code is not efficient, and it will reorder it. It is O3. O3 will do reordering, okay? Or silently know that there are two areas of code that can be run in parallel. So they may optimize a whole bunch of codes or swap your execution order, even doing parallel things using hyper-threading technology to do it in parallel. This is up to the compiler to generate the code. And when it generates the code, it will directly become a machine code. So I wish to skip the part in the generation of this kind of thing, the linker, the assembler, but make sure that you understand there exists something called assembler to convert the assembly code into some object code. The object code will do something called linking into executable code. But I don't wish to spend too much time. Okay, so something extra that you may want to pay attention to is about this declaration. Okay, so this declaration, I remember in Year 0 last year, I already teach you about this, and this is just like where's Java as well. Java, you can create a string object and equal like this, okay? And you can try at home to decompile it. Decompile means that use my example command here. Use my example command here. You can replace the C code with the previous, the code here, okay? And try to look at the assembly code to see what actually it is doing, okay? And I hope that someone will discuss with me in Facebook over this topic, okay? So I said I will skip something, okay? I will skip something. You go home and take a look over the extra things. Okay, I will skip. You can go on and take a look. And then we directly go to process creation. Okay, the process creation, why I want you to start earlier, because I want you to go home to try something. Okay, let's go. Okay, now this is important. Process, contains the code, contains the memory, okay, and representing your job. So it is a very important part which is irreplaceable. And what is said? What is said? Okay, I skip ahead a little bit. Go home. Try to execute this program for some time. First, I need to explain to you what this code is doing, because this is a dangerous code. Okay, it's called fork. Fog. Don't make any strange pronunciation. Fog. So this fog means that what? At that particular point of moment, you call that system call. Originally, you are the blue guy. Blue guy, okay? I use the wrong answer. Blue guy. And suddenly, you create a purple guy using that fog system call. Okay? Go home and try to use this fog system call by changing this code. This code already provided in GitHub. Okay, you can download it and try to modify it. And I give you some warnings. Don't use it with while loops. Why? Because this doesn't mean branching. It means parallelism. You create two processes and they run in parallel. And go home and tell me whether these two programs, okay, really running in this way. You have to go home and try. Okay? I have two questions. First of all, the question is, when you use a fog system call, whether this line, the first line, will be executed by the new process or the old process. So how to distinguish who is new, who is old? Okay? I already add a call in the slides. You can read ahead. On Monday, I will present it again. It's called get PID, just like your ID card number. Okay? Every process has an ID card number. Okay? And which is unique. Okay? And the trick is determine whether you are a young guy or old guy is by looking at the PID. The smaller, the older. Just like a Hong Kong ID card, right? Your cases are okay, my cases. Okay? The smaller number, the older. The bigger number, the younger. Okay? But there is exception. Later on we'll talk about exceptions. Okay? So go home, and I will call this a get PID. I hope that you will start discussing in a Facebook page what this code is doing. Or we will start the discussion on Monday lecture over this code. This code is important. Remember, don't use loop or any kind of loop. Don't call recursion. Yeah, you say, I don't do some kind of recursion. No, don't use recursion and call this fog system call, okay? And also what else? Don't use go to, okay? Yeah, that means that you know how bad it is, okay? If you're using while loop, you one become two become four become 8, and you need to put the computer. And don't write this program and put it in a computer or Apple Store as well. You know, Apple Store can create a terminal. I don't know why they don't have ways to remove the terminals. You have open terminals, BIM, save, CCC, enter, go. Very horrible. And you can try it on Mac Pro. Not MacBook Pro, Mac Pro. Yeah. Okay? Hands up. So we present this skip stuff, okay, on Mondays, and go on with the variation of using hot call. See you on Mondays. And I will be making an announcement over the next talk, as well as sample PMs that I will distribute to you. Thank you.